brain's natural electric activity, known as event-related potentials or ERPs. One specific ERP, the P300 wave, is crucial here. What if the brain itself could serve as a witness? What if hidden memories could betray a criminal even when their words don't? This is the promise of a forensic technique called brain fingerprinting. Welcome back to another episode of the Exhibit Chamber, and we are in Psychological Profiling Part 3, that is brain fingerprinting. The journey to brain fingerprinting begins in the early 20th century, when scientists first attempted to link truth and lies with physiological responses. In the 1980s and 1990s, a cognitive psychophysiologist named Dr. Lawrence Farewell developed a radical idea. Instead of looking for stress, why not look for recognition? The brain, after all, reacts differently when it encounters with something familiar. The principle of brain fingerprinting is a technique which relies on the brain's natural electric activity, known as event-related potentials or ERPs. One specific ERP, the P300 wave, is crucial here. It occurs when the brain recognizes a meaningful or a familiar stimulus. It can be a face, a word, or an object. In essence, if a subject's brain produces a P300 wave when shown details from a scene of crime, it suggests that the subject has prior knowledge about the scene of crime, a knowledge only the perpetrator would possess. So how does the procedure of brain fingerprinting work? Let's break it down. At first, the subject is fitted with an EEG headset that records brain waves from the scalp. He is then shown three categories of stimuli on the screen. Number 1 is the target stimuli, which is known to the subject for calibration. Number 2 is the irrelevant stimuli, which are the neutral and the unrelated information. And number 3 are the probe stimuli, or the crime-specific details only the perpetrator would recognize. When the brain recognizes the probe stimulus, say the murder weapon or the location, it generates a P300 wave within 300 milliseconds. The system compares brain responses across these categories to determine whether the subject's brain holds guilty knowledge. Unlike polygraph, this test does not depend upon emotions, verbal responses, or stress. It measures recognition, a far more direct indicator of concealed memory. But the question remains, can such evidence stand in the court? In India, Brain Electrical Oscillation Signature Profiling, or the BEOSP, a variant of brain fingerprinting, gained attention in the 2000s. Some lower courts admitted it in high-profile cases, but in 2010, the Supreme Court of India ruled that no individual could be compelled to perform this test without his or her consent. Moreover, the results are not admissible as primary evidence but only as investigative leads. In the United States, brain fingerprinting has been used in limited cases, but it has not been widely accepted in federal or state courts due to questions of standardization, validity, and peer review. Thus, while brain fingerprinting is an important investigative tool, its role in legal proceedings remains contested. Today, researchers are pushing the boundaries of memory detection. Newer brain mapping techniques are exploring beyond the P300 wave, incorporating advanced signals like the murmur, or the memory and encoding related multifaceted electroencephalographic response, a more complex brain response claimed to improve accuracy. Artificial intelligence is being incorporated into EEG analysis, allowing faster and more reliable interpretations of brainwave data. Coupled with functional MRI or the fMRI, these methods promise unprecedented precision in memory detection. But they also raise ethical questions of privacy, consent, and human rights. Overall, brain fingerprinting represents a fascinating intersection of psychology, neuroscience, and criminal justice. While it offers powerful investigative insights, its admissibility in the court of law remains limited due to concerns about reliability and interpretation. As forensic science continues to evolve, brain fingerprinting may one day provide courts with a stronger means of memory-based evidence. But for now, it remains just an investigative tool, but not a judicial one. So what do you think? Is brain fingerprinting the future of truth detection? Or is it another scientific tool waiting for stricter validation? The brain never lies, but interpreting its signals is a delicate art, where science and law must tread carefully. Thank you for joining us on the exhibit chamber. For more such videos, like, share and subscribe. Stay curious and stay investigative.